Okay, let's begin. I want to start by talking about this question, the question number 12, the one that I said yesterday. What a funny answer. Dia bilang answernya adalah D lah. Okay, so I went and researched it, and I think maybe originally I was overthinking this question lah. Saya terlampau memikir pasal ni soalan, but actually if you think about it, okay, the question is very straightforward lah. Okay, when the current in the primary coil increases, okay, the answer will be the magnetic field in the primary coil increases. Okay, simply simply because, okay, there is more current flowing lah. Okay, the bigger the Faraday's law. Okay, the bigger the current, okay, the stronger the magnetic field. The more the cutting of the magnetic flux. And the other answers all don't seem to make any sense lah. Okay, like the frequency memang tiada kaitan. We don't learn about frequency at this level. Magnetic field in the secondary coil decreases. Yes, it decreases, but dia memang akan decrease sedia. But if you increase the current in the primary coil, there'll be more magnetic fields here. So actually the magnetic field in the secondary coil will also increase. Okay, it won't be as much as, it won't be as, will also increase lah, but it won't be, how do I say this? It won't be like previously lah, before you increase the current in the primary coil. Okay, but I would say that, if you think as simple as you can, okay, you think about Faraday's law, okay, the rate of cutting of magnetic flux will influence the induced current. Okay, so when you increase the current in the primary coil, there's going to be more current. More current means a stronger magnetic field, and there will be definitely more cutting of the magnetic flux in the secondary coil. Okay, so the magnetic field in the primary coil increases lah. C memang cannot, because if there's more cutting in the secondary coil, there will be a definite more current or more magnetic field in the secondary coil. Okay, so I just wanted to address that question before we go to the rest of our tutorial questions for today lah. Okay, let's see how far we can do. This is our last class for this subtopic and also this chapter. Okay, so let's see how far we can go, and then next week we will start with a new chapter lah. All right. Let me see. Where did we end? We ended with this question, correct? Is this the last question yesterday? Did we answer beyond this? Did we answer this already?
Yes.
Okay, thank you. Sorry, who answered that just now? Was that Irdina?
Isabella.
Oh, it's Isabella. Okay, good. So Isabella, since you're the first one to answer, I'm going to ask Jacinta, the next in line. Oh no, sorry. I have to go the other way, right? I have to go the other way to save Shafiq Iqbal. Okay, so before Isabella is Irdina. Okay, Irdina, state the type of transformer, please.
Step-down transformer.
Okay, step-down transformer. Okay, let's go on to Elijah. Elijah, B1, please.
Mana satu, sir?
B1. What is that?
30.
30, okay, very good. Okay, so we use VP over NP. VP is given, NP is given. Okay, interestingly, the VS is also, sorry, the VP is 240, my mistake. Okay, the VS is 12. So this is definitely a step-down transformer. Okay, the number of turns originally 600, and then it is 30. Okay, current flow in the secondary coil. Damir. Oh, Daniel. My goodness. Sorry.
2 ampere.
2 ampere. Okay, very good. Okay, so we use the formula power equals to VI, and then after that you figure out and then you count 2 ampere. Okay, so electrical transmission cables that transmit electrical energy from one place to another. Apa maksud electric current? This is a chapter 3 question, but let's answer this. Damir, please.
Charge flow per unit time.
Okay, charge flow per unit time. Wow, skema jawapan betul. Okay, kadar pengaliran cas. Okay, the rate of charge flow. Actually, this is my preferred answer lah. Okay, the rate of charge flow. Okay, ini adalah jawapan yang saya lebih suka. Charge flow per unit time also can lah, boleh juga. Okay, but this is a better answer. The rate of charge flow. Okay, the power loss in the cable, please. Before Damir is Brandon.
1000 watt.
How do you get that?
I squared R.
Okay, very good. I squared R. The I is given and the R is given. Again, let me remind you, there is only one way to count power loss, which is using I squared R. You can never use P equals to VI. P equals to VI is generally power, okay, not power loss. Okay, very important thing. Good. Angeline, definitely I won't forget this. Okay, suggest the modifications that can be made to the model to increase the brightness. Okay, what can we change to the diameter of the wire? Eliska, sorry.
Small.
Small diameter. Why? Why small diameter?
To reduce the resistance.
To reduce the resistance. Okay, think about it. Wire kecil means kurang rintangan kah? Okay, very careful. Be very careful with this. Actually, it should be thick wire. It should be big diameter. Tebal. Okay. Saya pernah bagi tahu ini lah. I've said this. You think about electricity like a river flowing lah. Okay. Kalau dia punya, if your river is very big, very wide, very luas makan, senang untuk air mengalir. It's very easy for water to flow. But if your river is so sempit, okay, air mengalir very susah because there's a lot of resistance, okay, in that river lah. Okay, so we always use a thick wire. Okay, but the reason you gave is correct. Okay, sebab yang kamu beri adalah betul. You want to lower the resistance because the lower the resistance, higher the current, brightness is bigger. Okay, you have a bigger brightness. But remember this, kita guna wire tebal. Okay, we use a thick wire because it has lower resistance. Okay, number of turns in the secondary coil of transformer A. Adam.
More than the number of turns of the primary coil.
Okay, more than the number of turns of the primary coil, so that?
So the electric current is less, then the power loss is less.
Okay, I think that's a even better answer than the one that they give here. Okay, because you've already gone on to explain. Okay, more turns means high voltage means less current means less power loss. Very good train of thought. Okay, that's an excellent answer. You put an answer, so it's correct, but this is the given answer in this module. The train of thought is very good. Higher voltage, less current, less power loss. Okay, therefore brightness will be increased. Okay, name the material, okay, of wire X. It's either, okay, Wilson.
Copper.
Okay, if not copper, what is another material that is suitable?
What's that called again?
All your Coca-Cola tin is all made of this.
Aluminium.
Aluminium. Why do we use copper or aluminium?
Low internal resistance.
Wow, this is very good. Okay, yeah. Low resistance. Okay, let's try not to put internal because internal refers to battery usually. Low resistance. Okay, copper, aluminium. Actually, another very good material is gold. Gold is also very low resistance. But you don't see gold wires, okay? Because obviously, gold, everybody will steal gold, okay? But nobody wants to steal copper and aluminium. It's too easily found. Okay, so give one reason why an AC power supply is used in this model. Wilson?
AC power of varying magnitude and direction.
So? I'm not hearing the reason why. Why do we use... So what if it has varying magnitude and direction?
Magnetic field.
Magnetic field what? Poor Wilson. I'm grilling him. What is so important about the changing magnitude and direction of your magnetic field? Wilson or anybody? What is so important about this? What is so important about the changing magnetic field and direction?
Produce induced current.
Okay. I feel very, maybe because I have a set answer in my mind, right? And Wilson is, trying to get there. I think you're getting there. It's just that I feel I like saya tidak mau like tanya si Wilson lagi lah. Nanti dia stress betul. Okay, kenapa ini salah? Okay, my answer lah. Okay, my answer for this would be because transformer can only function with an alternating current. Okay, the answer they give here is the AC voltage can be stepped up. Okay, it means the same thing. Okay, only an AC voltage can be stepped up or stepped down because it has a varying magnitude and direction of the current, the magnetic field. Okay, but our basic go-to answer is that transformer can only work with an alternating current. That's why, transformer can only function, with an AC power supply. That's why we don't use DC power supply for transformer. Okay, so Wilson, you're getting there lah. Okay, I think you know what is meant lah. Okay, it's just that because this is a 1 mark question, kan? So you kind of want to go straight to the point. Okay, transformer can only work with AC. All right. Okay, next, diagram 8 shows how electricity is transmitted from power station to a school using transmission cables and transformers. State one characteristic of the cable that is used to make the transmission cables. Shim?
Yeah, thick diameter of cable.
Okay, thick diameter of cable, can, all right. There are actually many possible answers lah. Can be thick diameter of cable, it can be low resistance, it can even be high melting point. Okay, cables have to have very high melting points because there's a lot of heat that's going to be generated. Although we want to reduce the heat, we cannot run away from the fact that there is going to be heat. Okay, so we don't want the heat to melt the wires, because if the wires melt, then how is the electricity going to be sent? Okay, all right, B1, Shafiq Iqbal.
75.76 ampere.
Okay, how do you get that answer? It's correct, but how do you get
power,
the answer?
Power divided by voltage.
Okay, power divided by voltage, because they gave the power and we have to change the mega to 10 to the power of 6. Okay, voltage is in kilovolts, so we change it to 10 to the power of 3. Because power, we can only use watt, volt. Okay, we don't use megawatt. We have to change the mega to this one. Okay, okay, all right, Mordecai, B2 please.
3 million. Can
Kasih standard form lah.
3.
Hold on. Oh, Oswald is answering. Okay, kejap Mordecai. 9.9 times 10 to the power of 6. I think the 10 to the power of 6 is... The 10 to the power of 6 is correct, but the 9.9 is not. Okay? 9.9 is not, and I think I know why, but let's hear from Mordecai. What did you say just now?
3.44
times 10 to the power of
6.
times 10 to the power of 6. Okay, it could be, it could be, it could be, what's his name? Oswald, that you either substituted the I wrongly or you used V squared over R. Okay, it could be either one of these that is causing you to get the 9.66. Okay, but the good thing is you got the 10 to the power of 6, so that's a good thing. Okay, 9.9, 9.9 times 10 to the power of 6. So the good thing is you got the 10 to the power of 6, but I'm just wondering how you calculated this to be 9.9. Okay, power loss, ladies and gentlemen, once again, power loss is I squared R. No other formula for this. Power can be, different formulas. Power equals to V over V times I, or even power equals to V squared over R. Okay, it can be these two, but power loss is only I squared R. Because the only two factors that affect the power loss is the current flow and the resistance in the cable. All right. I don't think Melanie is here. Michelle, let's start with this. What is the material of the core that we should use?
Soft iron core.
Okay, why?
Easy to magnetize and demagnetize.
Okay, very good. Okay, There is no other answer to this. When we use soft iron core, the only reason is itu saja. So it's either you remember or you don't remember. Okay, you cannot goreng another answer. Okay, because it is a specific problem with a specific solution. Okay, so some people will find it easy to remember. Some will be like, why so difficult? Why can't there be more than one? Okay, shape of the core. This is a little bit tough, but can we give this a try? Who is next? How to say 3,443,564.738? Why are you suddenly asking this question? 3443564.73. Sorry, Wilson, why are you asking me this? Why are you asking this? Yang tadi tu power loss. Oh, okay. So if okay, let's address this lah. Since it's being asked, so the answer that you calculated, you got 738. Okay, 738 watts. Okay, if you give this answer in the exam, it is also correct. Okay, if you give this answer in the exam, it is also correct. Okay, of course, if you're going to give in standard form, usually kita tidak beri lebih daripada 2 atau 3 tempat perpuluhan lah. Okay, so you can go 3.444 if you want lah. Because standard form usually, the number of decimals, we don't want so many. But if you want to write this form, because this is what the calculator gives you, right? 3443564.738 also can. Pun tiada masalah. Okay, either way, it's also can. Because it's the same value, except that the 3.44 is already simplified lah. If changed to kilowatt, can. Why don't you change it to megawatt? If it is megawatt, it will be 3.44 megawatt. Astaga, my goodness. Sorry. 3.44 megawatt. Because 10 to the power of 6 is mega. Yeah, if you want to change it to megawatt also can. If you want to change it to, if you want to change it to kilowatt, it will be 1, 2, 3. It will be 3443.564 kilowatt. You will still get about the same lah. Yeah, changing to megawatt is good. But if let's say you don't want to change to megawatt, you want to keep it at watts. Okay, you give this answer or you give this long and complicated calculator answer, either way it is still correct because the numerical value, the 344 is there. That's the important thing. Okay, the 344 is there. Okay, does that alleviate your concern? Okay, let's continue. Sorry, where was I? I was with Michelle. Louis, shape of the core, X or Y?
Y.
Y, why?
Not sure, sir.
Okay, no worries. Turn off your mic first. Okay, so actually, we would prefer, if you actually use Y, it's kind of far, don't you think? It's kind of far apart, so we will actually use shape X. Okay, why do we use shape X? So that we can wind the secondary coil on top of the primary coil. Okay, or the primary coil on top of the secondary coil. Okay, so that there will be a reduce of the leakage of magnetic flux. If you do like this, the magnetic field can come over here, but it's so far it has to travel. Okay, whereas in this kind of setup, you can put both of them in, at the same place and one on top of the other, so that whatever magnetic field is produced in the primary coil will all terkena in the secondary coil. Okay, so this is the reason why lah. Okay, all right, let's start. NPNS.
NP bigger than NS.
Okay, NP bigger than NS. Why?
Because we want to make a step-down generator.
Generator.
Step-down transformer.
Okay, because we want to make a step-down transformer. Okay, because we want to decrease the output voltage. Okay, hold on. Let me check the question first. question already mentions step down transformer. So actually you can't use the answer that is given in the question, okay, as your answer lah. So you may have to word it in another way by saying that we want to decrease the output voltage, which is the function of a step down transformer, okay, to decrease the output voltage. And we use 20 to 1, okay, we don't use 1 to 20 because this is step up. But the reason why we use 16 to 1, the reason why we use 20 to 1 and not 16 to 1, because by using 20 to 1, you will be able to get 12 volts. Okay, so what happens if, let's say, you answer like how Lester answers? Then Lester just now said that the primary coil is more than the secondary coil. And then the answer, well, assuming that the reason he gave is because you want to decrease the output voltage. I would say this one and this one can. Okay, I would accept. Okay, but if you are going to use 20 and 1, you need to mention the 12 volts because, look at the question. Look at the question. Question says you want to go from 240 to 12. Okay, so going from 240 to 12, think about it. Going from 240 to 12 is equals to, if 12 is 1, 240 is 20. Okay, so about 20 times 12 is 240. So the ratio is the same. Okay, because you want to get an output of 12 volts. Okay, so that's the important thing lah. Okay, make sure you mention the 12 volts if you're going to use 20 to 1. So based on this, obviously the most suitable one will be R. Okay, this one I wouldn't ask anybody, this is too simple. We have the correct shape, we have a soft iron core, and we have the correct R ratio. Memang only one answer, okay, that can be given. All right, let's move on now. What is the meaning of the step-down transformer? Chris Fia.
A transformer that decrease the output voltage.
Okay, very good. Okay, basically basically the words decrease output voltage is the most important thing. Okay, explain how the output voltage is produced. This one, let's not waste time. The explanation is given. It is a 7-step explanation. So changing magnetic flux in the secondary coil will produce and induce electromotive force. Okay, so this is the 2-mark. If it is a 2-mark answer, this is what you will give. Changing magnetic flux, produce, induce electromotive force. You can go all the way and answer, all the 7 points if you want. But this is a 2-mark question. So you may need to simplify it a little bit. Okay, let's move on. Observe diagram 6.1 and 6.2. Compare. All right, let's do a comparison question. Jericho, can you compare all three, please? Compare the input, output, and number of turns.
The input voltage in 6.1 is equal to 6.2.
Okay.
The output voltage in 6.1 is bigger than 6.2.
All right.
The number of turns in 6.1 is bigger than 6.2.
Okay, very good. Okay, very easily done. Oh, sorry, can you do the fourth one also, the ratio? Oh no.
The ratio in 6.1 is smaller than 6.2.
Okay, very good. The ratio in 6.1 is smaller than 6.2. The numbers tell us lah. Okay, the numbers tell us. So it's a very easy comparison. Everybody, okay, must be able to do this. It's very basic skill. Okay, you do this every day, actually, without realizing it. Okay. Based on your answer in 6C, state the relationship between the ratio NP over NS and the output voltage. Jacinta. Wow, one round already.
The ratio is inversely proportional to the output voltage.
I don't like the words in. Sorry, I don't like the words inversely proportional in a paper 2 question. How do we answer this usually? Okay, I think I caught you lah. The bigger the ratio, the smaller the output voltage. We try to keep it separate. Okay, when we talk about directly inversely proportional, only if there's a graph. Because the graph actually shows us the relationship inversely proportional, directly proportional. But when we talk about, quantities like this, it's better to write it in a hypothesis form. Okay, the bigger the NP over NS, the smaller the output voltage. Okay, please take note of this. I know the answer here says inversely proportional, but I would prefer if you write it in the correct way. Okay, according to me, correct. Okay, let's talk about this. Emphasize aspects of, you want to make this into a more efficient transformer. Okay, let's have two people to do this. Isabella and Irdina. Isabella, can you do 1 and 2? Tell me the number of turns and the type of wire. And then Irdina, you do 3 and 4. Material and structure and way of winding the primary and secondary coils. The modification and why. Okay, go ahead, Isabella.
For the first one, the primary coil is bigger than the secondary coil.
Okay,
the
why?
reason is to decrease output voltage.
All right, very good.
And then the type of wire of coil used is thick wire. A reason is to reduce resistance.
Okay, very good. Okay, to reduce resistance, reduce energy due to heat loss, reduce heat loss. All these are standard answers. Okay, good. Irdina?
Material of core is soft iron core, easy to magnetize and demagnetize.
Very good.
The structure is laminated core to reduce the eddy current.
All right.
Way of winding, wind the secondary coil on top of the primary coil to reduce the leakage of field lines, magnetic field lines.
All right, very good, excellent. Okay, full 10 marks. Okay, of course. Okay, of course in table form lah. Okay, of course in table form. And as I said before, this subtopic is actually, if you think about it, it's very easy because every problem has a very specific solution. Okay, you cannot campur aduk. So when you make that match, bila kamu kasih match dengan betul kan, becomes very easy. Okay, very, very easy to remember. Okay, let's go to this next question. And this is a slightly different kind of making choice question. Okay, so the diagram shows you this one, and they show you 3 transformers. Okay, you notice that the original power station is 12, and then it is stepped up to 24. Come over here, it is stepped down to 8, and then stepped down further to 6. Okay, so this is a model power station. Okay, that generates 12 volts, and then it step up, then step down, then step down. So using the information in the diagram and the table above, okay, determine the type of core, okay, you will use and justify your choice. So the type of core in this is memang, solid lah. Sorry, what am I saying? Okay, the laminated soft iron core. We definitely don't want a solid soft iron core. Cannot. Solid means one chunk like that. Laminated means kepingan, then they kasih gum. So we want the laminated soft iron core. Okay, and then the material for the wire, it can either be copper or aluminium because these are low resistance. Okay, constant turn is kind of in the middle. Okay, but some people actually think that constant turn is also under the low resistance category. But nichrome and another one called tungsten, okay, these two are definitely high resistance wires. So we definitely don't want this. Okay, we definitely don't want nichrome or tungsten. Now the problem comes with the number of turns in the primary coil. Okay, the number of turns in the primary coil depends on how you want to step up and how you want to step down. You need to find pasangan yang betul in order to step up from 12 to 24, step down from 24 to 8, step down again from 8 to 6. Okay, and so if you take a look at the solution, we find that when they calculate, okay, you have to calculate according to the situation that they give. So for transformer P, the number of turns will be 500 and 1000. For transformer Q, it will be 1200 and 400. And transformer R will be 500 and 120. Because only these pairs will give you the same answer as this. 12 over 24. 24 over 8. Okay, only this pasangan saja yang boleh memberikan kamu pasangan berikut. Hold on, let me just check. Yeah. Okay, and 24 and 6 will give you this one. Okay, so we have to calculate it out. We have to experiment and see lah. Okay, let's say we want 12 over 24. Okay, kita cuba lah. Let's say, what if it is 400 to 500? Will I get the same answer? 400, 500. Okay, you won't get the same answer. Definitely won't lah. Or 500 to 400. No, sorry. 400, you won't get the same answer because 12 over 24 is 1 over 2. Okay, but 400 to 500 is actually 4 over 5. So it's not the same. Okay, so this is, I would say this is an interesting question because dia bukan soalan membuat pilihan yang lazim kita nampak lah. Usually we see and then we just choose one, right? But this one you have to calculate. Okay, you have to calculate and you have to create your own choices. So in transformer P is 500 and 1000. Transformer Q, so on and so forth. That's why at the end of this question, kan, although it is a section B question, we don't see make the best choice. And remember in this question just now, hold on. Okay, remember in this question just now, we have to choose between these transformers, P, Q, or R, which is the best choice. Okay, which is a section B question lah. But in this question that we are now doing, okay, we are not even given, we are not even told to make a choice. We just have to determine the pasangan of the number of turns of coil that is enough to make the step up or the step down happen. Okay, so if anything, I would suggest that you kind of star this question because this is Zurashi. This is a rare question lah. Okay, this is a very rare question that is interesting. Okay, that falls under the category of making a choice question. Okay, not modification. So this will be a section B question. Okay, so of course we use laminated soft iron core for all the same reasons lah. Okay, you can reduce eddy current. Eddy current is laminated. Easy to magnetize and demagnetize is soft iron core. If you give only one reason, also no problem. But of course, better to give both reasons lah, because you're talking about two solutions over here. Okay, we use copper is the best. Okay, because it is a small resistance wire and it is definitely lighter. Okay.
So
yes.
The transformer R bar, not 8 volt to 6 volt.
Yeah, you're right. Hold on. 24 come to here, come to here. Yeah, it should be 8 volts to 6 volts lah. If it is 8 volts to 6 volts, oh, hold on. Sorry, let me make this bigger. Oh yeah, you're right. It's 8 volts to 6 volts. So what should the pairing be? Is there a suitable pair? 8 volts to 6 volts. Is there a suitable pair?
Yeah.
Which one?
160 and 120.
160 and 120. 8 volts to 6 volts. 160, 120. Oh, okay. Yeah, sorry, guys. So change this. This is 160 to 120. This should be 8 volts. Okay, so that this pasangan will give us this pasangan, the same number. 8 over 6 is, sorry, 3 over 4, 0.75. Okay, so 160 divided by 120 is also 0.75. Okay, thanks, Shim, for pointing it out. Okay, let's go to we're almost done. Wow, I can't believe we're done. Okay, if the resistance of this one, can we have the answer, please? Elijah?
Also, at 0.8.
How do you get that?
24 over 30.
Okay, why 24 over 30? What is 24 and what is 30? Sorry, what am I looking at? Sorry.
I equals to P over V.
I equals to P over V.
KB.
Okay. But my question is, where do you get the power from? Where is this 24 from? The 30 is the resistance.
The voltage.
24 is the voltage.
Yeah. The transmission
Oh, okay.
line.
24 is the voltage. I is equals to
V over R.
V over R. Okay, very important. This is Ohm's law. Okay, so sorry, I have to push you to figure out. Okay, it's not just getting this law. Okay, so then the power loss due to the heating effect. Daniel, please.
19.2.
Okay, how do you get 19.2?
I squared R.
Okay, very good. Okay, so we use I squared R in order to get 19.2 watts. Okay, take a look at this, everybody. I just want you to note that it is a 5-mark question, but the working is like what? This is 5 marks. Okay, it's a very simple working, but it requires us to understand which formula to use. Okay, so I was like, why is it P over V? P over V. Padahal 30 is R and things like that. Okay, be very careful, okay, everybody. All right, this last question actually doesn't seem to have anything to do with the transformer, but we might as well try this lah. Okay, we might as well try this since we have a little bit more time. So, a pupil who constructed the motor made the following observations. Number one, the speed of the rotation of the disc is low. Speed of rotation of the disc cannot be controlled. The rotation of the disc is not smooth, dia tidak licin, and the dry cell loses its power in a short time. Okay, so when we study this design, how can we make the improvements to overcome these weaknesses? How do we make the speed of the rotation faster? How can we control the speed of the rotation? How can we make the rotation of the disc smoother? Okay, kasih licin sikit lah. And how can we make the dry cell not lose power in a short time? So this is actually, let me ask you, is this a generator or a motor question?
Motor.
Okay, this is a motor question. Okay, now when we think about motor question, we're thinking about 4.1. We're thinking about Fleming's left-hand rule. Okay, Fleming's left-hand rule to determine the direction of the force. So we're thinking about the catapult force and everything lah. Okay, kita sediakan current untuk menghasilkan the catapult force. The force is the one that causes it to flow. To flow. The force is the one that causes it to move. Okay, so let's not waste time lah. Okay, saya terus jawab lah ini. So the first thing is we use a lighter axle. Okay, the problem with this is the speed is low. So in order to make it move faster, we use a lighter axle, and if you can, use a lighter disc. Okay, so that it can rotate a lot faster. Secondly, we use a rheostat. A rheostat, we put a rheostat over here. Okay, in order for it to change the current flow. Okay, so it can control the current flow, can control the rotation of the coil. So this is the solution. Okay, the speed of the rotation of the disc cannot be controlled. Kalau kamu pasang ini saja with just one resistor, means the current that is flowing is very constant. So sometimes we don't want, sometimes we want it to slow down, sometimes we want it to be fast. Okay, so we use a rheostat so that we can control the current flow, and then we can control the rotation of the coil. Okay, and then the standard few answers, many number of turns of the coil. So instead of having one coil, we have more coil. Okay, can anybody tell me the reason why do we want to have many number of turns of the coils? You did this in your video, so I just wanted to make sure that you remember this. Why? Many number of turns of coils means?
More turning force.
Okay, more turning force. Very good. Okay, and then of course, another standard answer is that we use a curved magnet. What is another word for curved magnet? I always mention this one.
Semicircular permanent magnet.
Okay, semicircular permanent magnet, or there's another word for this. Semicircular magnet. Another word for curved magnet. I always use this word actually.
Radial magnet.
Okay, very good. We use a radial magnet. Okay, radial from the word radius lah. Okay, sorry, this is my favorite word lah. Okay, but Shim's one and even the schema jawapan here is also correct. Okay, I just like the word radial lah. Okay, because we can have a uniform magnetic field, we can have a concentrated magnetic field, and we can have a radial magnetic field. Okay, that's why I like to use the word radial, because the reason and the name of the magnet is the same thing. Okay, and then of course the other one is we need to use a direct current power supply. Okay, why do we use a direct current power supply? Because it is more stable, there's a continuous power supply, and most importantly, okay, the direction, okay, is one way only. Because remember, if you provide an alternating current, the disc is going to go like this, like this, like this, like this, which we don't want. We want it to continue to rotate it one way. So we use a direct current power supply, okay, instead of a dry cell. Sebab battery kan sekejap saja dia habis cas. And so we use a power supply, a direct current power supply. If you remember in our lab, I don't even know whether you guys remember what our lab looks like. Yeah, it's the place where you used to beratur every time there's physics, and then I will always take video of your lateness. Okay, so the power supply is a box that looks like this. Okay, with the yellow color buttons here, and then the red color buttons, red and black lah. Okay, then there's a butang here that can change 2, 4, 6, 8, 10, up to 12 volts. Okay, so this box over here, in case you all have forgotten, okay, is what we call the power supply. All right. Okay, good job, everyone.
Sir,
yes,
can you write greater number of battery use?
greater number of batteries. The direct cell uses its power in a short time. Greater number of batteries. It still doesn't solve the problem though, I think. Because the problem now is not that it's not just turning fast enough, but because of the time. Because of the time, dia cepat habis this one. So even if you use a lot of batteries, it still will be, after a short amount of time, it will still lose its power. Okay, we want a continuous power supply. You need to keep changing again and again. So even if you use a lot of batteries, you still have to change the batteries, which we don't want. Okay, we want it to be constant power supply. That we don't have to keep changing, unless the power supply suddenly pecah lah. Okay, which, yeah lah.
Okay.
All right. Okay, any other questions, anybody?